This is our third session in Advanced DevOps Lab. As I already told you, some of the portion of Advanced DevOps and DevOps is overlapping. And since I'm taking Advanced DevOps Labs, some of the portion of DevOps that is required that we will do in time-to-time manner, but simultaneously we'll keep steady pace of getting or completing our Advanced DevOps sessions. Okay. So we already know about what do you mean by DevOps. We already know about the IDE, DevOps IDE that is generally used, that we actually last session saw how to use in a collaborative manner for doing a collaborative project using AWS Cloud Service, whose name was Cloud9 IDE. Okay. Now, in today's session, we are going to quickly look at what do you mean by continuous integration and continuous delivery. Basically, we'll be focusing right now in our second experiment on continuous delivery. But the video that I'm currently showing you through my tab is about, it actually explains you continuous delivery, and especially it explains you it through the AWS service called as Code Pipeline. Okay, so we'll be understanding about what do you mean by continuous deployment and continuous delivery, that is CDCI, CD deployment and CD, the CDCI part, CD part we'll be concentrating on. For integration purpose, there are other software which maybe are referred to as Jenkins and some build tools, which we might not be looking at in this particular experiment. But in this second experiment, in this third session, we'll be first understanding what do you mean by continuous integration, continuous delivery, and how AWS Code Pipeline tries to achieve a seamless integration delivery, source code development, integration delivery in a set of services that are provided as platform as a service manner in a cloud-based environment. Okay, so let us not waste much time, and we'll just look at this video for say 10 minutes. It's a long video which also has a tutorial in it, which I will be showing you through the demonstration. We'll be giving you ample amount of insights how to go about and complete this tutorial and what exactly we are going to achieve. So we are not going to see this entire video. This video partly we will be seeing. So we have actually focused at 11:4 timeline in the video. Let me actually go a bit back as well. I don't know. Let me just pinpoint it to right timeline and then we'll start.
Okay. There, you have AWS services that actually help you carry out the DevOps or the CI/CD process with.
So this is this actually we saw earlier what is DevOps and exactly what all softwares help you in achieving this seamless integration and connection between developer through the integration, that is maintenance, into the deployment cycle. To make the deployment more robust, to make the redeployment more often than actually otherwise, if you follow some other standard practices of software development, would happen. So this we have seen. So we are not going to see this part. Obviously, there since it is a I guess here it starts. So we'll be talking today, or focus of our discussion today will be on the continuous delivery part. But since it's a good opportunity for us to learn what is continuous integration and continuous delivery, we'll watch this particular part of the video. Just confirm me that you're able to see the screen. Screen is pointing to a YouTube video, and it reads, the things read as what is continuous integration and delivery. I hope I'm audible and you're able to see the screen. If yes, just pinpoint through the chat window or maybe unmuting someone.
Delivery first.
Is the voice audible from the? Let me just check and then we'll start. Yeah, thank you all. I'll just start the video. So it's a 10 minutes video and it will be around half an hour to 45 minutes of the demonstration. After that, we may actually go back to a bit of, again, GitHub, the Git repository thing, and then we'll end the session.
So let's take a look at this diagram to understand this process. So these are the 4 steps that are there. You have split the entire chunk of codes into segments. So guys, think of it as more of your map reduce kind of an action. I mean, what happens is in your continuous integration and delivery, we are trying to bridge in the gap between the developer team and the operations team, right? So we try and automate this process of integration and delivery. So the fact that continuously you have various software updates, which I just mentioned, right? So what if I have like 50 or maybe 100 developers who are working parallelly? Now there are certain resources that need to be used by everyone, right? So what problem it creates is, suppose if I'm working on a particular code, I work on that piece of code. And if somebody else is working on that piece of code, and we have this central system where the data needs to be stored. So I'm working on this piece of code, I make a particular change and I store it there. Now someone else is working on this piece of code and that someone makes a change and he or she stores it there, right? So tomorrow if I come back, probably I need a fresh copy of this piece of code. What if I just start working on the piece of code that I'm working and then I submit that code there? So there would be an ambiguity, right? Whose code to be accepted, whose code's copy should be made. So we need this central system to be so smart that each time I submit a code, it updates, it runs tests on it and sees whether it's the most relevant piece. And if someone else submits their piece of code, then tests are run on that piece of code. This system should be able to ensure that each of us next time when we go and pick the piece of code, we get the latest piece of code and we get the most updated one or the best piece of code. So this process of committing the code, putting in that piece of code and automating this whole process so that as it moves further, it also gets delivered and deployed to the production in the similar manner with the tests that need to be conducted is called as continuous integration and delivery. Now, integration, as I've mentioned here, the continuous updates in the source code or the code that I'm building, the code is built, compiled. And when I talk about delivery and deployment, the pieces of code, once they're ready to move right? I mean, picking up the and tested again, then delivered and made sure that it gets deployed to the end customer the way it was supposed to be. So you can see that there are certain steps here. It says split the entire chunk into codes or into segments, keep small segments of codes into manageable form. Basically integrate these segments multiple times a day, which I mentioned that there should be a central system, and then adopt a continuous integration methodology to coordinate with your team. So this is what happens. I mean, you have a source code repository where the developers work, they continuously submit their pieces of code. Now, repository, think of it as a central place where the changes are constantly committed. Then you have a build server where everything gets compiled, reviewed, tested, integrated, and then packaged as well. Finally, certain tests, final tests are run to go through the final integrities, and then it goes to the production environment where this process, the building, the staging, and the committing process, it gets kind of automated to reduce your efforts. So guys, when you talk about AWS in particular, you have something called as AWS Code Pipeline, which lets you simplify this process. It lets you create a channel or a pipeline in which all these processes can be automated. So let's take a look at those processes as well. First, let's get through the definition part. Let's see what it has to say. I would be blankly reading this thing and then probably we'd be having the explanation part that follows. So as the definition says, it is a code pipeline, which is nothing but a continuous delivery service. We talked about continuous delivery already. And you can use the service to model, visualize, and automate certain steps required to release your software. Something that we've already discussed in continuous integration and delivery. So this is basically a continuous delivery service which lets you automate all these processes. So as I mentioned, automating these processes becomes very important. So once you do use this service, these are some of the features it provides you. It lets you monitor your processes in real time, which becomes very important because we are talking about deploying softwares at a greater pace. So if this can happen at real time, I mean, if there is any change and if it is committed right away, probably you're saving a lot of time, right? To ensure consistent release process. Yes, as I've told you, deploying servers is a difficult task and time consuming task. If this can be automated, a lot of effort is saved. Speed up delivery while improving quality. Yes, we've talked about this as well. And view pipeline history details. Monitoring becomes very important, guys. So what code pipeline does is actually it lets you take a look at all the processes that are happening. I mean, if your application is built, it goes to the source, then it moves to the deployment. All these processes can be tracked in the pipeline. You get constant updates as in, okay, this happened at this stage. If anything failed, you can detect as in, okay, this is the stage where it is failing, maybe stage number 3, stage number 4, and accordingly you can edit the stuff that has happened at that stage only. So viewing the pipeline history details actually helps a lot, and this is where code pipeline comes into picture. So this is what the architecture of code pipeline looks like. It's fairly simple, guys. So some of this might seem a little repetitive to you people because the concepts are similar. The concepts which were discussed, those can be implemented by using code pipeline. So yes, I've talked about these things, but let's try to understand how the architecture works. And we would be using some other terms and discuss some terms in the future slides as well, which we've already talked about. But each of these services, they do this task a little differently or help you automate these processes. Hence the discussion. So let's see to how much level can we keep it unique, and let's go ahead with this discussion as well. So let's see how the code pipeline works. Basically, there are developers, as I've already mentioned, these developers would be working on various pieces of codes. So you have continuous changes and fixes that need to be uploaded. So you have various services. One of them is code commit, which lets you have a initial source management system kind of a thing, which lets you basically take care of repositories and stuff like that. So it lets you directly connect with Git. I would be talking about Git, what Git is, but for people who know what Git is, if you have to manage your Git repositories, you have a service called as code commit. So this is what happens if there are any changes, those go to the source, your developers can commit those changes there, and then it goes into the build stage. This is where all the development happens. Your source code is compiled and it is tested. Then it goes to the staging phase where it is deployed and tested. Now, when I say tested, these are some final tests that have to be implemented before the code gets deployed. Then it has to be approved manually. It has to be checked manually whether everything is in place. And finally, the code is deployed to the public servers where customers can use it. Again, if they have any changes, as I've mentioned, those can be readily taken from them and it goes back again to the developers and the cycle continues so that there is continuous deployment of code. This is another look at it. It is very simple, but this is more from AWS perspective. So if there are any changes that developers commit, those go to the source. Now your data is stored in a container called as S3, that is simple storage service in the form of objects. So if there is any change that has to happen, the data is either fetched from the storage container, which is S3, and the changes are built. And then again, a copy of it is maintained in the form of zip. As you can see here, there are continuous changes that are happening and those get stored in the S3 bucket. Now, S3 should preferably be on the region or in the place.
Yeah, as I paused the video a bit, the reason behind that is I need to give you certain explanation. So what exactly is going around in this video is right now they're talking about what a code pipeline looks like and how it is matching the actual development cycle in a DevOps. Okay, so there were 5 phases written over there, some related to development of the code, maintenance of the code, and then building of the deliverables from the code. Before that, there were certain integration tests and other things performed, and finally staging it to the production site. Now, when it comes to a web application or a web service, generally the staging area would be, or the deployment or production area would be the intended host on which you are going to run your server. And this is where different services of AWS we are going to get used for. Okay, for the staging and production level side, the delivery side, that is continuous delivery side, the responsibility is of the AWS service called as Beanstalk, AWS Beanstalk. Okay, so this Beanstalk service is responsible for continuous delivery. As far as build is concerned, code build is the service from AWS which is responsible for building the code. So it actually lets you build for various different kind of software platforms. I may build a web application, I may build an Android application, I may build a Python application, Java application, or any more. So there could be many more different kinds of source codes which this code build can help you build dynamically. So you just define the rules of building the source code, and you provide the source code through the source channel, and then this build service would automatically, once it gets a revised source code, will try to build it. If it can build it properly, it will make it forwarded to the staging area. But before forwarding it to the staging area, it takes care to store everything into this S3 bucket. Now, what is this S3 bucket? So S3 is another service that is used here. So we talked about already one service called as AWS Beanstalk, responsible for continuous delivery. AWS code build, responsible for building the source code that is available given to it whenever the source code gets changed, so that the build image should also match the changed source code. Next, that we are talking about as a service of Amazon that we will be using is called as S3 service, Simple Storage Service, SSS, Simple Storage Service, that is why S3. So this S3 service does what? This actually stores the blobs or binary large objects. In any kind of data store I want, which is not a structured form data, which is a blob kind of a data, can be stored over here. And obviously a source code is kind of a blob data. It's a binary large object data. So I will be storing my source code in this S3 bucket, multiple forms. Once in the source code form that is delivered from the source of the source code, the place from where I have pulled the source code before I build it. After building it, whatever the outputs of build are there, the system that I have built, that resultant or output source code is also now not a source code, but executable code is also stored in S3 bucket. So everything actually is in the cloud, stored in S3 bucket, Amazon S3 bucket, as far as the DevOps pipeline, especially continuous integration and delivery pipeline is concerned. So whatever are the byproducts, or whatever are the data products that are generated during the code pipeline, they are stored in this particular service. Okay, so that is important to say. And the source part, actually, there are different services of Amazon using which I can also maintain the repositories in the Amazon cloud. But since we are at this moment not going to talk about any Amazon service for storing the source code or maintaining the source code as a version control system, we will be talking about GitHub as a third-party version control system, wherein we will actually upload our code, and from there, whenever the GitHub source code is updated and checked out, that is, the update is complete on the source code, whatever changes we are making are in place in the source code, then that source code will be pulled to this particular source in the pipeline, and from the source of the pipeline it will be forwarded to the build stage automatically, and the build stage will automatically send it to the staging area. From there, it is up to the deployment team whether they want to connect it to the deployment site. That is, if it's a web server, I may actually attach the staging area of the pipeline directly to the EC2 instance, which is a compute instance on which I will create the deployment configuration, and whatever deployment footprint is generated, the code is generated, that deployment code, I will be transferring it to over there into that particular instance. So these four stages, or these four steps, or these four AWS services we will be using today in our discussion of code pipeline. And why it is called as pipeline is because generally when you live in a city, the pipeline is the infrastructure that provides you the facility that on your demand, when you open the tap, the water runs through your place or your home from the river. So the entire thing is automatically set up in order that it eases the job of the deployment engineer or the person who is actually opening the tap, the user basically, so that everything is working in concert with an event-driven architecture. So something changes in the code and the code is updated. The application that maintains the code informs, or the source gets that information by pulling that information into it. The source of in this particular pipeline, which that acts as a plug between external code management system and the code pipeline. Once the code comes to the code pipeline, it sits into the S3 bucket. The build once gets to know or understands that there is a new code than the previous build, it will automatically try to build the code based on the information that it has. Once the build process is complete, that is, I create the executable, I will put again the redded image of my executable production system into the staging areas, and also maintain a copy and some metadata, I should say, some extra data about what information, what actually that particular build copy represents, which source code it represents, how it is different from the previous one, and all those things are maintained as metadata, which will help me in order to understand what changes have been there in the production system than the previous version of the production system. Now that staging area in the code pipeline is also attached to the actual production system, and that way we'll have this entire thing referred to as a pipeline. If you remember, we talked about this word pipeline when we discussed about command line, that is bash, wherein one command's input is sent as output, one command's output is sent as input to the other command, and then further this can carry out a series of computation from one command to the other command, joining commands together using the vertical pipe. So that is also called as pipe. So this word code pipeline comes from this insight of computing, wherein we actually do not write any particular script or a program, but in order to achieve certain computation, we rather write certain commands and we connect their input outputs so that the desired operation is carried out. And that's why this particular feature of Amazon, or the service of Amazon, I should say, is referred to as code pipeline. And internally, this single service called as code pipeline uses multiple other services which comes under Amazon services, which are called as developer services. One developer services we already talked about is IDE. Okay, so my source maintenance system may also have that IDE service, or I may not have that service. So it's flexible. Basically, this code pipeline is basically a flexible one. Okay, I will go back to the discussion that is there in the video. I hope this is understandable and not confusing. I stopped it because I wanted to make sure that whatever I say later is also in consent with, because जो डेमो में दिखाने वाला हूँ उसके साथ मैं ये वीडियो को मैच कर रहा हूँ. And the demo, they are slightly bit different because this video is 2 years back and there are some updates in the interface of this code pipeline, and there are differences in the steps as well. Okay, so we will be leaving this once the explanation is over, and we'll be seeing the actual demonstration in afterwards, after this particular video is over. I'll just continue the video.
Where your pipeline is, that helps you carry out the process of continuous integration and delivery with ease. In case if you are concerned with multiple regions, you need to have a bucket at each region to simplify these processes. So again, here to the code gets to the source. It is probably submitted to the build stage where the changes happen. A copy is maintained at S3, and then it goes to the staging. Again, a copy is maintained, and then it gets deployed. So this is how the code pipeline works. And to actually go ahead and implement all the actions of code pipeline, you have a service or these services, that is your code deploy, build, and code commit in AWS. So these services actually help you carry out some or most of these processes that are there. Let's take a look at those services and understand what do they do. So first and foremost, you have your code deploy, code build, and code commit. So this is not the order in which you deal with these things. Now, these things actually help you in automating your continuous delivery and deployment process. They have their individual commitments. Let's talk about them one by one. First, let's talk about code commit, which is last in the slide. So basically, I talked about moving your piece of code to a central place where you can continuously commit your code and get the freshest or the best copy that is there, right? So code commit, what it does is it helps you manage your repositories in a much better way. I mean, think of it as a central repository. So it also lets you connect with Git, which itself is a central storage or a place where you can commit your code. You can push and pull that piece of code from there, work on it, make own copy of it, submit it back to the main server or your main or central operating place where your code gets distributed to everyone. So that is Git. And what code commit does is it lets you integrate with Git in a much better way. So you do not have to worry about working on two different things. It helps you in automatic authorization, pulling in the repositories that are there in your Git account, and a number of other things. So yeah, that is what code commit does. Then you have something called as code build. As the name suggests, it helps you automate the process of building your code where your code gets compiled, tested, certain tests are performed, and again, making sure that artifacts or the copies of your code are maintained in your S3 and stuff like that. So that is what code build does. And then you have code deploy. As I've already mentioned, deployment is not an easy task. I mean, if we are stuck in a situation where we are supposed to manage the repositories, we are supposed to work on quite a few things. In that case, if we are forced to kind of take a look at the servers as well, spawn new instances, spawn new piece of servers, that could be a tedious task. So code deploy helps you automate these processes as well. So this was some basic introduction to these things. Let's just move further and take a look at the demo so that we can talk about some of these terms and the terms that we've discussed previously in a little more detail. Now, in one of my previous sessions, I did give you a demo on continuous integration and delivery. I believe there were certain terms that people felt were taken care of in a speedy way.